All right, guys. So we are picking back up, going to finish talking about iteration here, and then some of the practice problems that my friend was going to be working kind of on his own time. So if he got stuck and had questions, then we'd come and talk about them. But otherwise, he was going to try to be practicing on his own as we keep making progress. Well, we will circle back to a couple of those and talk about them after we finish some more discussion of loops and iteration here. So yesterday, we had been talking primarily about for loops. So we'd done some examples with lists of numbers here and going through each one of the numbers in the list. And we talked about how Python kind of prefers this syntax of the for each loop, which is really simple. You just say for the item in your list of items, you're going to do something. But you can also use the range function in Python to generate a list of numbers to go over. And that list of numbers will correspond to the indices in a collection. And so we did some examples with lists yesterday. We said that if you get the length of a list, then that will be the stop value for the range function, because the range function actually, as we've in here, so I'll go ahead and redo that in a second there. The range function here actually has a couple of different definitions. This is called function overloading, which we'll get to eventually. But you can see that there are multiple ways to call this function. You can either call this function with a single integer value, and that's the stop value, which will be you basically go up to but not including that value. And the default values for start and step are going to be 0 and 1. So if you just give range a single number, it will start at 0 and count up until the number you give it. And you can also get more complicated and change the start value and or the step value so that the range function returns a somewhat different set. So we used an example of printing out the even numbers here in this list. And then we've done that with, in this particular example, we hard-coded the things. Now, it occurred to me that if we ever wanted to be a little bit safer when we do this, we really probably ought to do in this code right here, where we are using this, we really ought to put the length check right here. So we really ought to check the length. That is the bounds of where we're going to go. Second, because in the real world, you don't almost ever want to actually hard code things. So this will start at 0 and go up to the length going every 2. That's really more how we would want to code this one. Does that make sense?
Yes.
Why I would make that point here, because it works fine if you hard code it, but that's only because we have this up front. Well, what happens if you're going to have a program where the user is going to input some stuff, and then you're going to put it in an array, and then you're going to check the length? Well, you don't know the length deterministically then. And so we would want this to work for all lengths. So that's one point. Very common to have the length of a variable determine what things you iterate over like this. In some other languages, you don't use a range function to generate indices. You just, iterate over a list of numbers in general, like I had mentioned up here. That's what for loops look like in many programming languages. All right, so that's for loops. I think we've got the hang of it pretty good here. So I'll that back out. What was here was something that I left as a brief exercise yesterday after we finished. Was okay. So we talked about the start and the step values and how range has a couple of different possibilities here. Now, when we give it 2 values like this, the first one's the start, the second one's the stop, and then step defaults to 1 still. So if we print this, so if we go ahead and we run this, you can see that it is indeed printing out 4, 5, and 6, which is what we wanted. And so you got this one right. It really is not supposed to be particularly challenging. So if we look at our array, we see we have indices 0, 1, 2, 3, 4, 5, and 6. It's exactly why I started at 0. So each one of these words corresponds to the index that it's at in the list. And we said that we wanted 4, 5, and 6. And so quite simply, you start at index 4 because the first part of the range is inclusive. That is, if we were to write out the bounds on this, we would have start is less than or equal to wherever we are is less than stop, strictly less than. That is exactly how the inputs to range work. And so we give it 4 here, and we know that we have 6 indices in our thing, and we don't include the last one. We go up to but not including. And so that's why we have 4 and 7 here. So you have any questions on that, or to make a good sense why this works how it does?
Questions. Except there was no way to actually hard code that bit, right? Because I was addressing myself just that specific array, right?
Yeah, that's correct. If I had said get all values from index 4 up to the end of the list, would you be able to do that though?
Yes. Yes.
And so what would go here if that was the
all values from index 4, right?
Mm-hmm. To the end.
Yeah.
Yep.
To the end. So that would be what was it? -1, right? Whatever it is. No, -1 is like the end. Yeah.
Okay, so this should print just 4 and 5. I don't think this will print 6. Or, maybe it doesn't do anything at all. Because you can use -1 when you're indexing, right? But
okay, but not when I'm in the range function.
Doesn't
right?
look like in this range function that works.
Okay, so then it would be len -1. Something like that.
So we'd have the length of one.
Something like that.
I still think this will be 4 and 5, but not 6. And that's because we have the exclusive here. So does the length give you the last index, or does it give you one greater than the last index? Think about that a second.
It gives the last index. That's true. So
It does give the last index. Are you sure?
doesn't
So let's
it?
count how many things are in this array. You agree that the last index here is 6, right?
Yeah, so that's 7.
1, 2, 3, 4, 5, 6, 7. The
Yes.
length function will actually give one greater than the last index, and that's because things in Python and most programming languages, but not all, incidentally, but things in most programming languages are actually indexed at 0, which means you start counting at 0, not 1. However, length starts counting at 1. And so, in fact, and this is, by the way, not done unintentionally, because it means that you can do this. So actually, you just need the length, because this length is actually one greater than the last index.
Yeah. That's the length. Okay, I get that.
Yeah.
Yes, it does.
Okay, I think that's probably most of what we'll do with for loops. Much of the time you'll probably just do for thing in list of things. You won't probably actually use the indices here unless you need to do something like we've done here, like you want to do every other one, or you want to start at a particular thing and not do everything. Although actually, incidentally, let me show another way to do this. So this is with the range function that we're doing this, right? So you remember the syntax for slicing, right? Well, if we want to do if we want to print each number string here, we can actually index into the list of numbers here without ever actually formally having to use the range function. So if I do that, do you know what that means?
Yeah, it's slicing index 4.
Mm-hmm. And if you remember the slice syntax, same deal here. That one is starting and including 4, and that's to the end. Well, if we do this and we print the number string here, this should actually be the same thing, right?
Yes, it is.
And so sometimes you can actually use slicing on whatever the thing you're doing, you don't actually have to use the range function. I mean, either way, either one of these is absolutely fine. And in fact, I don't really think there's a huge difference between them. Although, like I said, especially here in Python, this is probably the approach that is most commonly taken because it's kind of easier to read, right? You know, so you're going to get this thing in your group, and then you're going to do something to each individual one. All right, well, I will come to control flow statements here in a second. In fact, I was just looking at this a second ago. We'll come back to this. I want to do while loops first. And so, you know, I will start with just the basics of a while loop, and then we will go from there. So for loops go over the entire collection of things. For loops operate on collections or lists or some finite group, right? Well, what happens if you have something where you don't want to just iterate over something finite, but you want to keep going until some condition happens? That is when a while loop happens. So a for loop executes just for the elements that you have in, you know, some collection or, you know, some set of things, some finite set. And while loops are, you want to keep going until something happens. So the example that I'm going to start with here is going to be using a search, and we are going to set a flag variable called found. And so basically, we are going to have a function where we say, like, let's say find the value. Okay, so let's say that we are looking for value 4, and we are going to take in my list of numbers here. So we have a list of values, and we're trying to find the value 4. So for the purpose of this, we can just say that when we find the value 4, we're going to return it. So we could, you know, use a for loop with break, which I will talk about later. But for now, let's say that we have a variable called found, and we're going to set found equal to false. Okay. And then this is going to be my example of while loops. I'm not going to ask so many questions when I do this one, but we are going to set the while condition to not found while we have not found the thing we're looking for. What we're going to do is we are going to compare the value. And actually, we can do this with a, I have to keep track of which index we're on too. We're going to do I'm purposefully maybe not writing this in the way that, you know, sometimes we might otherwise write this, just so that I can show you, like how while loops work, basically. Okay. Do you want to see if you can explain in words what this code will do here?
Yeah. So it will take in the lists, that's list of numbers, sets, the counts, something incremental to 0, and set found to false as a default.
That actually needs to be outside the if statement. I hadn't had that initially.
So then it will iterate through the list looking for the entry 4. If it does find it, it will set found to true instead of false and break out of the loop. But as it goes through each of the elements of the list, if it does not find 4, it increments the counter by 1 and retains the initial Boolean value found.
Oh, false, right.
Yes.
Okay,
So it
so yeah,
keeps.
that's the basic. Now you'll see that this is pretty contrived. Okay, like there, you see, we're keeping track of an index. One of the reasons why I'm pulling this up initially is just to show you that you can still use indices when you use while loops. There's no reason why for loops have a monopoly on them. So everything you can write as a for loop, you can also write as a while loop. Does that make sense?
Yes.
Or do you need me to say it again?
It makes sense. I understand.
Everything you can write as a for loop, you can also write as a while loop. And how do you do that? Well, you just do exactly what we're doing here. You do a count like this, and then like you would implement, if you were strictly doing it like how we would do a while loop, you would go while count is, and then you would say count is less than the length of, what do we call it, list of numbers. This is with the count variable and this statement. That is exactly how you emulate a for loop in a while loop, and then you increment every iteration. Now we're mixing it up a little bit. We are saying we want to find this particular value here. Okay, so we have an if statement inside the loop, and we also have the incrementer here. Now, you see how right now we're resetting the value of found if we hit this statement in the if statement. Do you see a way in which we could simplify this code? I'm not actually catching this myself here. This is control flow wise, this is kind of what we're doing, but you see a way in which we can get rid of a line of code?
Well, not really. I don't.
So do you remember when several days back, we were talking about returning things in functions that return a Boolean? And you were writing code along the lines of, if the condition is true, return true, and if the condition is false, return false. And I said you could just return the condition.
Yes, you did.
Does that ring a bell?
I see that, yeah.
And so do you see something that's parallel here?
Yes, we could eliminate found equals true and simply do return true.
Well, do we want to return in this case though?
That was what I was just wondering, because you were returning the list of numbers itself.
So we don't actually want to return. We can just assign it though.
Okay.
So can you think for a second, does this make sense, what we're doing? So we just replace the condition where if found is equal to true, if the list of numbers dot count is equal to 4, then we're going to set found equal to true. And that case still works here. And then the other case is, well, if this isn't true, it's going to be false. And before, when we had just this, when we had just this, if this statement wasn't true, this didn't get executed and the value of found was false, right? And now, given that we've done that, if that statement is false, the value of found still is false. Now we actually reset it, so we're setting the value, but we just managed to successfully eliminate a line of code, right?
Yeah, I get it.
Okay, so that's one option. And then at the end, you see that the value of count will be retained when we break out of this loop. And so when we run this here, let me go ahead and comment out most of our examples here. So if we go ahead and we run this, we should see that the value of this should be 4, right? Because what we're going to do is we're going to break out of the loop at the count here where we are on 4, and then when we index into it, we should just get the string 4. We run this, and looks like we're not getting anything at all. Interesting. Did I capitalize things? Oh, it's because I haven't called it. Like I didn't think I made any mistakes here. So we want to then call this function In fact, we're going to want to print it because we're not actually printing it there. We're going to call the value of this function with our array from up here. Or not array, list. Like that. Don't want to. That make sense?
Yeah.
Now it should actually print out 4. Except it prints out 5. Interesting. Aha. I see what the problem is. This is actually an error on my part. Let me see if you can figure it out. Not sad it happened because it'll be good practice for you.
It's supposed to print the value 4.
Mm-hmm.
So why does it print 5?
So the breakpoint, right? It's the best way. We have an expected value. Our function is not returning the value that we expect. The best way to figure out why is to go step through the code. Right? I've got it now. It's kind of a stupid mistake, honestly. You'll laugh. Where are the breakpoints? Okay, so now we're stopped on our breakpoint. We're in the beginning of this function here. And so we see that when we step here, we're going to start out by initializing those 2 variables. So count is 0, found is false. So we are now going to step inside of the while loop, and stepping through these loops works just the same as stepping through for loops. You know, in the examples that we've already debugged with loops, you know, you see you just step at the end of every iteration, you jump back to the top of the loop. That part still works exactly the same here. So, you know, we will see that we are just going to keep changing the value of found here. And so the first time we're going to check is the count is 0. So is the first value, let me actually copy the values down here just so we have them for a second. I can't, whatever. List of numbers, as you'll see, if we expand that out, is just the indices 0, 1, 2, 3, 4, 5, and 6 in a list over there, right? So the first time we do it, what is list of numbers count going to be?
0.
The string 0, right? And the string 0 is not going to be equal to 4, so this statement should return false. And so if we step over this, we expect found to still be false, right?
Yes.
And then, okay, we didn't find it on this one, so now we want to increment and we want to go to the next one, right? Makes sense. Okay, so now we're on the second one. Count is now equal to 1. So this one should be the string 1. Is 1 equal to 4? No. So we're going to keep doing that. 2 is not equal to 4. 3 is not equal to 4. Okay, now we're on 4. So now we expect this to be true, right?
Yes.
Huh, interesting, right? See, it is true.
Yeah.
So you might be scratching your head right about now and being like, well, why is the value wrong then? So watch what happens after this. So counts at 4. We know that index 4 is going to have string 4. That's what we want, right? So let's see how we get to the end of the function where we're returning the object that we want to be returned, right? So if I step again, what happened to the value of count? You still there?
Yeah, yes, it's true.
Not the value of found, the value of count. You can look over in the debugger, remember.
Sorry, I lost my connection for a little bit there.
Okay, you know, let me completely stop and we'll get back to that state then. As I was wondering, because I wasn't sure if you'd heard me or not. So we're going to go through until we get the value 4 again. See, where are we? We have count is 4, found is true, and we're stopped right before this line here where we have count. Okay, so now if we step one more time, now we're back at the top of the loop, but what's the value of count now?
Value of count is 5. Yes.
And do you see why that makes sense?
Because count plus 1 comes after found.
And so
So
now when we return the value of the list at count, suddenly we're not returning 4 anymore, even though we broke out of the loop when we had 4, right? And so you can see actually that I violated one of the principles when you write while loops is that whatever changes the condition of iteration, whatever changes like what's controlling whether you keep going or not, should honestly always be at the end. And I didn't do that, and that's exactly why, right?
Okay.
Now, do you think that this one will work here?
I think it should.
Okay.
Okay, just a minute, because it seems a little counterintuitive to me, because if you have count at 0, while not found, you're incrementing count before you actually checking for the condition.
Mm-hmm.
Doesn't that mean that you don't check the first?
That's correct. So I was going to see if you're going to catch this or not. So if we come up here and we're calling this with this list here, right? Now, if we make another list and we call this one just third, and then we put the value 4, not at index 4, but we swap 4 and 0. Let's say we do that. And then we call our function here with the third list of numbers. So you said it seems like we increment count before we check the first one, right? So we do that here. See, we also try to index out of range at the end because, we're going to check something in the list, right? But we didn't find it. And so this code actually, every single time you get to the index, even if we write this function correctly, like how we had it written before, you would still throw this error because actually we're not being type safe when we're checking the bounds, right? So this is an advantage right here that for loops have over while loops. You never have to worry about this because if you have a defined collection in a for loop, it will handle, basically being kind of like range safe for you. You can't like track off the end if you're using a for loop because Python itself is controlling the indices there. So we have this problem. Now I brought this up as well because I wanted us to talk about error handling, exceptions. So let's do one thing at a time though. So first we were going to be fixing this +1 thing. So there's actually a way for us to make this function. If we always assume that the value of 4 is inside the list, we actually don't even need to track, iteration with this variable here. So right now we're using this Boolean variable to control iteration. But if we say, you know what, it doesn't matter, we can guarantee that this list always contains the value 4. We can actually iterate simply on the value of true. Now, this is dangerous a lot of the times because what happens if the list doesn't contain 4? And what happens if the list is really, really big?
Yeah,
You'll just keep going, right? It's called an infinite loop, right? Infinite loops are bad because your program sits there and does nothing. And it's consuming CPU cycles, doing all the instructions repeatedly every time, but it doesn't do anything. So infinite loops generally dangerous. There are some circumstances when you will use this, and I'll give it another example down further. So if we do that, and rather than tracking this value of found, what we do is, well, we're going to put this back in an if statement. So we are going to, just for the moment, we won't worry about this. We will if, and then we put this check back in a conditional like how it was before. And then we put this actually inside of that there. Now, do you think this will work or not?
It still increments within the while loop.
Mm-hmm.
But it returns the list of numbers in spite of that. So, okay, so the count will break out of the while loop. The incremental will break out of the while loop, but the what will be returned is what we are looking for rather than the count.
Well, actually, no, we're still indexing into the list with count. So remember, the initial problem we had was that we were returning element 5, not element 4, right?
Yes, yes.
And so what I'm asking is whether we still have that question. And the answer
No, we don't have that problem now.
is going to be no. And why is that? Because look at the order here in the code.
Yes.
It's because we want this condition is going to be true when count is equal to 4, right? When count is index 4. And then we're going to be returning the thing at that point in time before we've incremented count again. So this actually should return 4, right?
Yes.
Okay.
Yes.
So that's good. Now we've eliminated the variable there. So this is, again, making the assumption that this list actually does contain the value 4. So you can actually return directly inside of lists, right? And so what we're doing here is we're kind of short-circuiting the loop. We're saying, I don't care how much we iterate, honestly. Like, we don't have to go across everything. We just need to go until we find the thing that we want to do. So this is how you would do this with a while loop, assuming that the value is there, right?
Yes.
So this concept of, well, I want to go until I find the thing, and then I don't want to do it. So returning is an easy way. But let's say rather than returning, let's say you just wanted to use that value. So like, let's say that after finding the value of 4, we want to do something like, we want to like capitalize the first letter. So capitalize 4. I mean, this is completely arbitrary. You never actually want to do this probably, but what we would do here is you know what? Let me rewrite this as a for loop. Sorry, that was not the most elegant transition. So let's say rather than breaking out of this loop, we want to track the So now let's say we want to return the capitalized version of our value here. So we're still going to be searching for the string 4 in this array. And now I'm using this keyword here called break. Have you ever heard of break before?
Yeah, I have.
Okay, so break means that you actually stop execution inside the loop. And so this actually, I believe this should work. Yeah, so it gives us the value of capital 4. So how the flow of execution here is working is, see, now we have a variable. We're going to be storing the value. I mean, in this particular case, we could actually just hard code it, but, you know, like, bear with me, it's an example. So we're going to store the example, or we're going to store the value in this variable here. And then after we store the value in the variable, we're going to break out of the loop. And so if we step through this, we put our breakpoint there on the conditional. So we're going to start our execution with the value of count being 0, and then we're going to go, we're going to check the condition. 0 is not equal to 4, so we're going to increment count. 1 is not equal to 4, so we're going to increment count. 2 is not equal to 4. 3 is not equal to 4. Okay, now we're on 4. So now we're going to hop inside this conditional. And so now we're going to set the value of our variable here. And so the value of our variable, which started out being initialized just to an empty string. Well, after we execute that first statement, the value of our variable is now the string 4, right? Does that make sense?
It does.
What our assignment statement. And now what this statement does right here is it says, whenever you have a break and a break gets hit inside of a loop, you're just gonna hop out of the loop completely. So we have a while true here, but we have a break statement. And so after we hit the break statement, we're just gonna step out of the loop completely. Does that make sense?
Mhm.
Okay. So now we've out of the loop. This statement here, we're just taking a capital letter F, and then we're going to take all of the values in the string for, except for the first one, and that first value is the lowercase f. And then when we do that concatenation, you'll see that capital value of f now has the value capital F4. Okay, so that's capitalizing it, and then we're just going to return that. So does this function make sense now with the break?
Yes, it does. But there's one question. It's obvious that the while loop continues to increment until it hits the condition that we're looking for.
Mm-hmm.
Why does it not actually break without incrementing at all, since the break statement comes before incrementing?
So do you see the indentation level here?
Okay.
It's because this break statement is actually inside of this if statement, right?
Okay.
And so the reason why we would not break is because we're not breaking here until we actually find the number 4. So each other time when we were checking, this condition was 0 in this list of numbers, but that was the word 0 equal to 4. No, that means that these statements aren't executed. Is 1 equal to 4? No, that means these statements aren't executed, right? So it's not until we actually have 4 equals to 4, where this conditional is true, that we actually execute these lines. And so we're only going to break once we actually find the value 4.
Okay. But the count is actually operating on the if statements outside, that's within the while loop,
Yes.
rather than
Count. And this is super important in Python. Many other programming languages will use, well, I can't edit over here, but I mean, we've stepped through it. Many other programming languages won't use indentation. Well, I mean, actually they will. This is considered by far best practice, but they'll actually use curly braces like this to make it very clear what is inside of a block and what's not inside of a block, right? Now, Python doesn't. So indentation is very, very important in Python because it's the only way you know what's inside of what else. Both of these statements, and you see the line here, both of these statements are actually inside the if statement. This statement is not. This statement has one more indentation level. It's in the while. And then this statement down here, so you see how we're losing a tab each time, right? So these statements are inside of the if statement that's inside of the while loop. This statement's just inside of the while loop. And this statement is actually outside of the while loop.
Okay.
Okay, so where I was going to segue us is we can actually write this function with the for loop as well. There's no reason. I mean, this is, like I said, super contrived example, but me with my clever naming. Okay, so we're also going to take in a list of numbers. Just for time's sake, I'm going to write this one too. Otherwise, I might have you do it. So here we are going to use the for each loop. So we're going to say for each num in list of numbers. We're going to have our check again here. If here we don't even have to index into it, we can just say if num equals 4. And to mimic our structure here, we would have that variable initialized outside here. And then this bit right here will be exactly the same. Does that make sense?
Second. Yeah. Yeah, it does.
Okay, so if we print this out, also get capital 4. So this is just me showing that the break statement also works in for loops. And one of the ways in which this is most useful is in basically short circuiting, like we're showing examples of short circuiting find statements, because you can actually return things directly. So there's two ways really to short circuit a loop. So if you're in a for loop and you're looping over the entire list of numbers, what happens if your list of numbers is like 1 million numbers long and you happen to find 4 on like the second number? Well, you don't want to go loop over the other 1 million numbers, right? Because that's really wasteful. You already found the thing that you're looking for. And usually you won't just be looking for a number. By far, one of the most common cases of this is you get a list of things from a database and you want to find a specific one. So like, let's say you have a company has a list of employees and you want to find the employee named John Smith. Okay, well, actually that'd be terrible because there's probably more than one. Let's say that you want to find an employee with employee ID equal to like 22 or something. You know, most employees that work at big places have like an ID number for this reason, right? It helps disambiguate between names. And so you would have a list of employees. It could be really big. It could be thousands of people. And you want to go find the information associated with this person. So you have an ID number and you have a list of records that's sort of keyed by ID number. And you want to go find the list of records until you find the one for the employee. Well, if you were to go over the entire list of records and you weren't smart about when you returned, you wanted to, you know, like break out of the loop. So you didn't want to go check everything and then return the index, right? Because then you've just, you know, gone over a whole bunch of records that you didn't need to. This is what I'm talking about makes sense. So if you are writing a function that you can just return something after that. So in the case that I'm talking about specifically, you would probably go over all the records in the company, and then you would probably return the record that was corresponding to the ID. That is a function that we actually write those every day in my job, something like that. That would be a so-called get function. So in web applications, you have various operations. You have like get, post, create. So this get operation is one of the things that you do if you have an item in a data in like a web application. An API is what they call it, an application programmer interface. Well, you might want to get the object, you know, to have information to do stuff with it. You might want to actually create is not one, post. Sorry, delete. I don't know why I was thinking create. Post is when you want to create one, you post something to the server saying, hey, I want to create a new one of these patches. You want to update it, and delete it. You want to delete it, right? So-called Crud operations. So Crud being an acronym here for create, read, update, delete. So this is read, this is create, this is update, this is delete. So you do Crud operations on things all the time. And what we just talked about here is at a very high level, that's how in production code all around the world, that's how people will do Git. Now, of course, they'll optimize their data sets, and there's a bunch of interesting stuff with probably hash tables underlying some of the lookup, and databases might do some of this directly as well. But the point is, the general pseudocode for, I have a list of things, I want to find one, and I'm not using something like binary search because it's not sorted, if you've ever heard of binary search. There are ways in which you might be able to speed up the execution. But if you're doing a simple linear search, the best way to do a simple linear search throughout the entire list is to execute until you find the thing you're looking for and then break out of the loop, which is exactly what we just did. Okay, sorry to go on the tangent there. Just thought maybe you'd find it interesting to, you know, this particular example, super contrived. However, the general concept that we're talking about here, you know, going through a list of things, and if you find the one that you're looking for, break, that is actually used all the time. All right, so I don't have too much more time this morning. So how about we go and for the moment here, we will come back later and you'll see that, you know, I may not actually go over this super explicitly. Let me just put this page here as a link. there are other control statements other than just break. So break obviously breaks you out of a loop. There's also something called continue, which is, let's say that I wanted to do something to every element in the list, but if a certain condition is met, I just want to skip that iteration in the loop. So here's their example here. They say, we want to print all of the letters in the string Python except the H. Okay, that's what they're saying, right? See this code right here? So they're going to say for each letter in the string Python, they're going to print the current letter, except they have this conditional up here where they're saying if the letter is equal to H, then they're just going to continue. That means that this print statement will be skipped. When you continue, you just jump back up to the top of the loop for that bit of the iteration.
Okay.
And so you can see here that PYT, there's no H, it's just ON, Python. And that's because they're going to skip that one in the thing. And same deal here. You know, here's a example with a while loop. So they set the variable equal to 10. While variable is greater than 0, they're going to decrement it. And then if the variable is equal to 5, they're going to continue. So they're not going to execute the rest of the body in the while. And then they're going to print each thing. So this should skip the letter 5 while counting down from 10. So you see 10, 9, 8, 7, 6, no 5, 4, 3, 2, 1. Does that make sense? Kind of.
Yeah, kind of.
So maybe it's kind of hard to understand here just because neither of these cases seem like they're very useful. Let me try to come up with a case where you really might do this. So let's say that some employees are hourly and some employees are salaried. Okay, I'm using company databases again because they make good examples. So a company has a list of employees. Some of the employees are hourly, some of the employees are salaried. And let's say that you have a function where you are going to be calculating the salaries of hourly employees. So you're going to multiply their salary, like how much they make per hour, by how many hours they work. You know what? Do I have time to program this? I think I do. Let me actually write this out because this will be a much more helpful example in seeing the value of continue. Now, those are the only two that we're actually going to talk about here. The other ones, I mean, like pass the else statement with loops. I mean, like you can do this. This is a very Python thing to do. Other programming languages don't have this, so it's just confusing for the most part. Pass literally means it's a no operation. It's a do nothing, which if you have a do nothing, you can just not have anything in your code. Again, Python thing, maybe not used as much. I mean, like if you want to like make it explicit, hey, if this happens, do nothing, then you can use this keyword. But yeah, I mean, neither of these quite so useful. Continue and break, you will actually use like regular. I mean, not regularly. I don't use it that often, but like knowing what they are is actually very useful. Okay, so the example we just had here is we have a list. In fact, here, maybe in the course of this will help you with the dictionary one. So you're saying you having problems with the dictionary one. Well, I'll do an example that really isn't terribly related, but you know, I'll actually use the same general dictionary here. Where am I? While loops, employees. So I'll just rename this to employees. Let's give these people some more reasonable hours. Let's say this person worked 30 hours a week. This one worked 26. This one worked 40. And this one worked 45. And this person's pay was like $9 an hour. This person's pay was $5 an hour. I have a bad job, I guess. This person's pay was $8 an hour. And then this person's pay was $11 an hour. Does how I'm defining this make sense? So we have a list of names here, and the names are mapped to a list of dollars or of hours and then dollars respectively. Now, if I were to modify this so that mixed in with these people, let's add a Mr. Bob Jones. Bob Jones, rather than being something mapped to a list, we're just going to give him a number. We're going to say that Bob Jones makes $43,000 a year. That's what Bob Jones makes. Okay. And then we got to add a comma so it won't scream at us. And then let's add another person, Charlie Magnuson. Good name, Charlie Magnuson. Mr. Charlie makes, let's say he just makes $42,000 a year. How about now? Does how I've set up the data now still make sense? So we said some people are going to have hours and dollars because some people are hourly and some people are salaried. And so the salaried people just have a number.
Yeah.
Okay. And so now we want to write a function called compute salaries. So we're gonna write our function here called compute salaries. And what we're going to do def. We're going to take in employee dictionary. Okay, so the first thing that we're going to do is we're actually going to go over all of the things in the dictionary. Now, this may have been where you've gotten stuck, so this may unstick you immediately. So dictionaries have a for each loop, and sometimes you might want to do something like this. If you just do a for loop with the, let me do it real quick just to show you. If you just want to print the keys in the dictionary, that is the things over here that you're mapping things to. I guess we haven't really gone over dictionaries super formally either, have we? Dictionaries, rather than indexing with numbers, you can index dictionaries with basically whatever you want. And so here we're indexing dictionaries with strings. And so to access, here, even before I get there, to access the list for John Smith, if I want to access John Smith's information, the value here in this dictionary, what I would do is I would use the dictionary employees here, and then I would index with the name John Smith, because that's the key that's being used in the dictionary. So we're saying the thing to the left of the colon is what you will use to index to get the specific values in the dictionary. So let's say I'm indexing with John Smith here. Well, it's going to print out 30 and 9.0 because that's the information for John Smith. Does that make sense? So rather than lists, which index with numbers, dictionaries index with strings. Typically, that's what you'll use for dictionaries. You can actually use other data types if you'd like as well, but dictionaries map one thing to other things. So other programming languages will not call them dictionaries, they'll call them maps. And that's because that's exactly what this does. So apologize, this is going kind of fast, but we are going to have an example here. So we said that you can actually iterate over all of the keys in a dictionary just by using a simple for loop, like a for each loop in the dictionary. So if we do this, we should get John Smith, Colin James, Bob Jones, Ashley Carter, Charlie Magnuson, and Stuart Duncan. If I were to actually call the function.
Okay.
It's because I didn't call it the same. There we go. Exactly as I said, right? So the other thing that you can do is you can actually put a comma there, key value and employee dict.items. So items, if you go check on the W3 Schools website, items is a function that dictionaries have that returns these things as it might be tuples. I don't actually know, whatever. But you get the key value pair. And so if we want to print the key and then let's concatenate that with a space and a dash, and then we want to print the value, this should give us, actually value probably isn't a string, it's probably going to throw an error here. So we are going to need to convert this to a string. And if we do that, this should print out the keys and
one last
537.
parenthesis.
You're correct. Yeah. So now we're printing out the names and the salaries, right? So this is how you enumerate things in a dictionary. So let me finish because I have to go to work in probably the next 10, 15 minutes. So I want to finish this function. I'm sorry, I know I'm going really fast this morning here, but
I'll go over it again myself.
okay. Now we're going through the keys and the values, and we decided that this function here should compute salaries for the employees that are hourly. So for now, let's just assume that we're just going to print them to the console. You know, ordinarily you'd probably store those in a different file or make a different object for them or whatever. But right now we just want to compute the salaries and let's just print them out. Okay. So now the thing that we want to check here is if the employee has a list, has a list of two things, that means that they're hourly, right? So right now we have no way to tell that employees are hourly other than hourly employees have hours, and then they have a salary, and the salaried people just have a number, right? So
yes,
let's see if Python has a function to check data typo, because you agree that right now the difference is that one of those things is a list and one of those things is a double. So what we want to do is do something if something's a list and do something else if it's a double. So you see, look at this. First thing that we did when we typed it into Google was, oh, look, there's a function called type. And if you stick in a list, type will return list. And if you stick in a dict, type will return dict, and so forth. So what we want to do now, I actually haven't tested this. I'm learning this too, right as we go. But this is how I would learn it. I would say, okay, so we want to do one thing. So we want to do if type of value said is list. That was one of the options there. And then elif type value is, what does Python even use? Is it float? Is it double? I think it's float, right?
It's float, yes.
Okay, yeah. I mean, other languages have a double, which means double point precision. So let's say we want to print out the computed value here, and actually we don't even need this particular line. I was just doing that. That is how we would check if it was a salary. But right now we don't actually care for the salary. We only want to do things if they are hourly, which means that the type of value should be list. So what we should do if it's list then is to calculate the salary. So let's say calculated salary is going to be equal to list. Oops, not list. It's going to be equal to value, which we decided is a list because we've done our type check here. And then we're going to multiply that with the second thing. So if you wanted to make this more clear, actually, let's be really clear here. So we would say that employees' hours are equal to this. This is probably more readable code, so this is what I would suggest. And then hourly rate is going to be equal to this. And then we do hours times hourly rate to get the calculated salary.
Okay, that solves my problem.
Right, and I purposefully picked one that's pretty similar to the task that I'd left for you up there. We'll go over that tomorrow probably.
Okay.
But this should probably get you unstuck because it's pretty similar. It's a pretty similar problem. Okay, so wait, how did I even get into this? I was looking at continue. Okay, so this one is going to be doing this for all of them, right? So I'll get to the continue in a second there. But for now, let's see if this works. So I see no reason why it shouldn't. We've done all of our checks here. We're going to go through. We're going to look at the ones who are hourly employees. So they have a list, which means they have hours and a rate rather than just a salary. And for each one of those guys, we're going to calculate or gals. We're going to calculate the hours, the hourly rate, calculate the salary by multiplying those two, and then print the person's name and the calculated salary. So if we do this, we would anticipate that this would print this row, this row, this row, and this row. Does that make sense? Or sorry, not that one, that one. All the ones that are lists. So let's see how good I am. Well, can only concatenate string. So I guess we do need that right there. So learning to instantly interpret error messages is one of the things that you'll get better at as a programmer, right?
Okay.
Boom.
Okay.
And let's sanity check ourselves. So we said that John Smith has 30 times 9. So 3 times 9 is 27. So 30 times 9 is 270, right? 26 times 5, oof. Well, 5 times 20 is 100, and 5 times 6 is 30, so 130, that looks right. 4 times 8 is 32, so 40 times 80 is 320. And 45 times 10 is 450, so 45 times 10 is 495. Does that make sense? So now let's get back to the example. Sorry, got a little bit off track there. Let's go back to the example of, let's say now, so we're calculating salaries there. Let's say we want the def salary of, so here we have this calculated salaries function, right? Except rather than having our condition here be, simply if it's anyone with a specific type. Let's say that we know that the person who we're gonna put in here, let's say we know that they're hourly, so we know we're gonna have to compute it. Okay, so we're still gonna have to go through the list like this. Or sorry, my brain was muddled. I'm sorry, it's morning for me. The thing that we might want to otherwise do is, rather than setting up the logic like this, see where the value is the list, this inherently skips ones that aren't a list, right? Now, if we wanted to set things up the other way, let's say here that we write a helper function for this. I'm sorry, I was trying to figure out where I was going with the continue thing. Let's say that, and we are going to give it list. We're going to make a function that gets called here. I gotta put def. All right, so let's say we want to return the string version of the calculated salary like that. What does it look like? Okay, it's because we haven't finished this yet. So usually when you're using continue, you might be able to write it in a way in which you wouldn't have to use it, but sometimes it can make it very clear. So let's say we wanted to check instead if someone's a float, right? So if the value of that we're grabbing from the dictionary is a float, then we want to continue. We want to skip that one. Otherwise, we want to all right. Let's give it a sec. I only have like 5 minutes left, but let me see if I can explain this here. So how we've changed this function here is, previously we had an if statement, and that was going to be inherently ignoring the people in the employee dictionary that were salaried, simply because they didn't have a value type float. Now we're going to kind of reverse the logic. We're going to say if someone is, if their information is of type float, that means that they're salaried, right? Because the folks that are hourly have a list. The folks that are salaried have just a float, a value with a decimal point, single number value. And so now we're going to say if the type of the value is float, then we're just going to continue. And what that means, based on the discussion we had here, with break and continue is you're just going to skip that iteration of the loop. And so if they're salaried, we're just going to skip that iteration. And by skip, we mean that we're not going to execute the print statement, right?
Okay.
That makes sense. And now the print
Yes.
statement I've just refactored. This is good. Keep your methods clean. To just take in the info list for a specific person. We're still going to grab the hours. We're still going to grab the hourly rate. We're still going to do the multiplication. And then we're going to return the stringified version of it. So let's see how good I am.
Okay.
Is it going to work the first time? No, it's not. Because why? Hmm. Oh, well, it's because of that. 562, that's not on the screen. All right, so let's see. Yep. Didn't print the names this time, but those are the numbers we had before, right?
Yes.
So you saw how we had two different ways of doing this, right? And so you could either do it this way, how we have it here, or so I'm going to put this one underscore continue and put this one underscore conditional. So if we check, you see that these two things right here are exactly the same. In fact, in the terminal, I'll show you here that these two are exactly the same because I'll call them on both the same dictionary here. So we run that, we're going to get exactly the same values. So I have to run to go to work, but this was just me showing an example of where using continue is actually useful. So if you want to do something to everything of a certain data type, but not to things of a different data type, you might use continue, right? And actually, more specifically, you see right now, if you have a simple binary list like this, it's pretty easy because either you do one thing or you do the other thing. What happens if you have, what happens if you have 5 different data types? I really do have to go soon, but let's say I make another thing where we're going to make dictionary and then so let's say 1 is an integer, okay? Say 2 is going to be a float. This becomes much more important when you're doing object-oriented programming and you're using different kinds of types. So you might have different types that you're defining and you want different behavior to happen only for certain things. That's when something like this would be. So I'm making up an example right now. That's a list or contains nested dictionary. Okay. So what happens now? So you see here, we only had 2 types. Well, you could write something. I'm not actually going to write a function here, but you could write something to check if, let's say you have this for loop. Well, you could write something that would be like this. So let's say we want to do something to everything that is, let's say we want to do something to everything that's a number. Okay. So we could check, no, let's do this. This will be enough to give the example. So we just have an int, a double, or a float in a list. Well, we could check if something is a float like this. Or we could check, it's not auto-completing my parentheses properly. Or we could check if it's an int like this.
Okay, yes.
So that's one option. You see what that's doing? That'd be getting the numbers. But it's actually simpler. It's simpler to check. Well, so I'm trying to show an example of continue here. I keep coming up with ways in which you can get around it. I mean, I'm not trying to say continue is bad, but so in this particular example, since we have a determined list, we could say as long as it's not a list, that means it's one of these, but I like negate the logic. But the other way in which you could do this is you could check if, you could check if the type is list, right here.
Yes.
And if the type is list, then you would continue, right? And you see how checking one thing here is actually simpler, because what happens if we had a whole bunch of more types? What happens if it wasn't just 2, if it was like 5? It's actually way easier to ignore the one that you want to ignore specifically than to come up with a check to check all of the ones otherwise, right? So
yes,
that is some logic for why you might want to do it. And you might, so if you know which type you want to ignore, but you don't necessarily know all of the types otherwise, then continue is very useful, because you don't have to manually specify, everything that you would want to use ordinarily. So the most common case when you will be ignoring, when you'll be using continue, is if you want to do an operation for like certain kinds of data, but some things won't meet the criteria. That's when continue comes in useful. Okay, so I actually have to run to my job. Like I said, sorry we went a little fast there, but hopefully you have some actually more useful examples as to when you would use this, what the differences are, how you can refactor. If you don't like continue, you can usually get rid of it if you want by using conditionals in some way. But there you go, more examples with loops, and hopefully this got you unstuck on your dictionary practice problem, which is up here. Yep. All right. Well, I will talk to you tomorrow then, because I got to go to work.
okay.